Hello and welcome to our geodetic tutorial. My name is Janine Hilden, I'm an application engineer at Math2Market, and in the following video I will show you how to create a bimodal anode. This can easily be done with the Bimodal Anode Geo app, which is introduced in Geodetic 2023. This video is the second video in the small series of videos on how to create a battery from bimodal electrodes and run a degradation simulation on it. You can find the app in Geodetic by selecting Geo app up here, and then choose Battery, and then Electrode Generation. In the Module section here, in the bottom left, the Electrode Generation Geo apps available in Geodetic can be selected from the pull-down menu. Since we would like to generate a bimodal anode, we select this app. Let's click Edit to have a look at the parameters. The parameters are similar to the ones for the cathode. For the domain size in Y and Z direction, we need the same values as for the cathode to build a battery from the two electrodes. The domain size X, which is the charging direction, we change to 75 voxels because this is a common thickness for an anode. Also, the voxel length must be the same as for the cathode. We will create a non-periodic structure, so keep the selection here at No. The active material of our anode will be graphite. Then we can set the D10, D50 and D90 values for the three diameters of the particles. For the cathode, spherical parameters were generated. But here, for the anode, we have either ellipsoidal or polyhedric particles based on ellipsoids. Thus, we have a short, a long and an intermediate diameter to control. Similar to the cathode generation, we will use a second particle type with the same material but another diameter distribution. For the particle shape, we choose convex polyhedrons, since this shape fits better to the graphite particles. Note that the generation with polyhedrons takes much more computational time and resources than the generation with ellipsoids. The orientation tensor controls the orientation of the single grains in the domain. Refer to the FiberGeo or GrainGeo handbook of the Geodetic User Guide for a detailed explanation. We also keep the settings for the electrolyte and the CBD phase. The criterion to match will be by loading, as we did for the cathode, and we use the same loading as for the cathode, 2.1, and set the tolerance to 5%. We leave the maximum number of tries at 2. Then 2 different random seeds are used for the structure generation algorithm to reach the loading within the given range. We don't need to specify a random seed or other stopping criteria for the moment. Now just click OK and run to generate the anode. On my laptop it took around 4 hours. Here we can see that the desired loading is achieved with only a very small deviation. The porosity is about 10%. Looking at the structure, we see that the structure has 2 graphite particle types and binder in between. This is the end of the second video tutorial in this series. I showed you how to create a bimodal anode in Geodetic 2023. In the next video I will build a battery from our 2 electrodes to perform a charging simulation to then perform a degradation simulation on this battery in Geodetic. If you found this tutorial helpful, please check out our Math2Market channel for more Geodetic videos. Goodbye!